Hello everyone, and we're going to continue dividing complex numbers here by rationalizing the denominator, getting the I out of that denominator. Now we're going to move on to denominators that contain complex numbers, not just pure imaginary. So now they have that extra real number that's in front of the imaginary number. So here that -8. So the way that we're going to have to now get rid of I, we can't just multiply by I anymore. Because if I multiply by I, it's going to distribute to that -8, and I'm still going to have an I in the bottom. So the way that we get rid of i's when we have a complex number is we multiply the entire fraction, both the numerator and denominator, by the conjugate of the denominator. So the way you find the conjugate of the denominator is you go ahead and take the first part of this complex number, which is a -8. Right? It doesn't really matter that it's negative or positive, doesn't change anything. I'm going to take that 8. Then I'm going to take this 5i. And then the way that we make this a conjugate, the one thing we do change is the sign in between. Whatever's in between needs to be the opposite for the conjugate. So in this case, negative becomes a positive. So the conjugate of -8 or -8 minus 5i is -8 plus 5i. Again, the negative in front doesn't need to change, just the sign that separates the real number from the imaginary number. And of course, like we said in the last video, whenever you multiply the bottom by, you also need to multiply the top by that same thing. Okay, so what we get now is in the top, we're going to need to distribute the 1 to -8 plus 5i. So what ends up happening there is that is going to just stay as -8 plus 5i. And then when you multiply the bottom, the conjugates, you would need to treat it like they are two factors in a quadratic and FOIL them. But in case you forget, the way that there's a pattern to multiplying conjugates, and the way that pattern looks is you're going to square the first number. So in this case, -8 would be the first number. So I'm going to square that to make 64. And then you're always going to add the two together. So then I'm going to add, and I'm going to square the coefficient in the pure imaginary number, which is 5. Right? So just that 5 is going to get squared, and that gives me 25. Okay, so when you're multiplying conjugates, in this case, the -8 minus 5i times -8 plus 5i, you take the first part of it, which would be the -8. So I take that -8 and I square it, and then always plus. And then you're going to take the 5, right? And we don't really care about the sign here because you're going to have a plus and a minus. Doesn't really matter. You then take that 5 squared, right? And then that leads you to the 64 plus 25. Okay, so then what I'm going to do is now I can write this as -8 plus 5i all over. And then I'm going to add those two together, and it looks like we get 89. Okay, and then that is our answer. What we want to look for is we want to see if there's a common factor in those three numbers, the -8, the +5, and the 89. And it doesn't really matter what the signs are. So 8, 5, and 89, they do not share a common factor. If they did, I would have to simplify that, but they don't, so I can move on to the next problem. Okay. And the next problem, same thing. Doesn't really matter what's going on in the numerator. The denominator has a complex number, so I'm going to need to multiply by the conjugate. The 9 doesn't change, the 8i doesn't change, but the sign in between becomes the opposite. So instead of 9 plus 8i, it's 9 minus 8i. That gets multiplied in both the top and the bottom. In the bottom, it works out nicely. You take the 9, square it, plus the 8 squared. In the numerator, you're going to have to FOIL these two things together. You're going to have to treat it like a -5 minus 9i being distributively multiplied by 9 minus 8i. And we'll take a look at how that's going to look. Right, we are going to multiply the -5 by 9 to get -45. The -5 by -8i gives us +40i. negative 9i times 9 is negative 81i, and then negative 9i times negative 8i is positive 72i squared. Right, don't forget, in that case, they both had an I to write the I squared because that is going to make a difference. And then in the bottom, 9 squared is 81 plus 8 squared, which is 64. Okay, I've done all the multiplying of the complex numbers. I just need to simplify here. So the first thing I can simplify is I can combine the middle terms here, plus 40i minus 81i. So that would give me the negative 45 doesn't change. Plus 40 minus 81 is minus 41i. And then remember, I squared is negative 1. So I can substitute out that I squared for negative 1. And then in the bottom, I can just add those two together. So that's going to give me 144. Right? 145. 81 plus 64 is 145. And then I can keep simplifying because this 72 times negative 1 is going to make that a negative 72. Right, so basically I squareds change the sign on whatever has an I squared. So this is going to become a minus 72. And then I now can combine the minus 45 and minus 72 to get negative 117. So negative 117 minus 41 over 145. I'm sorry, it's minus 41i. Forgot the I there for a second. Negative 117 minus 41i over 145. And again, I want to see if negative 117, negative 41, and 145 had any common factors. In this case, they do not, so that is our answer. And then we'll take a look at one more. We'll go a little faster. Again, I need to multiply by the conjugate, which is 3 plus 4i in both the numerator and the denominator. In the bottom, I'm going to get 3 squared plus 4 squared. In the top, I'm going to have to FOIL. Negative 4 times 3 is negative 12. Negative 4 times 4i is minus 16i. 10i times 3 is plus 30i. 10i times 4i is plus 40i squared. And then I'm going to need to simplify some stuff. So the first thing I'll do is combine the two middle terms. Minus 16 plus 30 is plus 14i, and then the plus 40i squared becomes minus 40, because remember, I squared is negative 1 times the positive 40 is minus 40. 3 squared is 9, 4 squared is 16. Negative 12 minus 40 is negative 52 plus 14i all over 25. And again, there is no common factors in these three terms. So that's our final answer. Now, don't stop yet. I am going to show you what you would do if there was a common factor. So this is just a little extra problem. Let's pretend I had something like 4 plus 6i over 8 as my final answer. In this case, 4, 6, and 8 all have a common factor of 2. When those three terms have a common factor, you can divide and factor out that actual factor. So it has to be in all three of them. If it's just in two of them, it doesn't matter. You can't cancel anything out. It would stay as is. But when it's in all three of them, I can factor this 2 out, and it's going to cancel and just kind of disappear. So then this would be 4 divided by 2, which is 2, 6 divided by 2, which is 3i, and 8 divided by 2 is 4. So that would be the final answer, right? So you would have to get rid of a factor like that. It didn't happen in any of our examples, so I hope you stayed on long enough to pay attention to that just little piece of information there.